Alright, we are on lesson 18. Our objective says, I will be able to use rules of positive and negative integers to combine like terms. Basically, all we've got to work on today, or what we're going to use when I say positive and negative integers, I'm thinking about same signs, add and keep, different signs, subtract, that sort of thing, okay? So if you know how to do that skill, you should be good on what we are doing today. But before we do that, you've got to know what like terms are. Like terms are terms that have the same variable, underline that, raised to the same power. Like terms have the same variable raised to the same power. So here's an example. 3x to the fourth and 5x to the fourth. They both have an x raised to the fourth power. Because the variable x has the same power, these are like terms. Now notice, same power and the same variable. Notice that this 5y to the fourth, this is not like terms. Even though it has the same power, it does not have the same variable. Y and x are different, okay? So those are unlike terms. They're like terms if they have the same variable raised to the same power. If they do, you can combine them, okay? Here, 5x plus 7x. Do these have the same variable raised to the same power? Yes, they both have an x. It's not raised to a power. There's an understood 1 as a power there, but they have the same variable, so I can combine them. 5x plus 7x. All I have to do is combine the coefficient. Combine the number that is out front. Combine the coefficient. So 5 plus 7 gives me 12x. 5 plus 7 gives me 12x. Here, I've got 6xy minus 3a plus 4yz, or excuse me, yx. Now, the commutative property says that the order of factors does not matter. So even though this says xy and this says yx, they still have the exact same variables, x and y, raised to the same power. They're not raised to a power. So even though the order is different, you can still combine these. So I can combine 6xy plus 4yx. That's going to give me 10. Again, I'm just combining the coefficients. 6 plus 4 gives me 10. And then that xy, I'm going to just keep them in alphabetical order, but the order does not matter. Now that I've combined these two, I can mark through them and see that I still have a minus 3a. So bring down your minus 3a. Now, can I combine these two? No. This has an a, this has an xy. Those are not like terms, so I cannot combine them. Can only combine terms that have the same variables raised to the same power. Let's go here. Alright, I've got x to the fifth plus y to the, what is that, third, plus x to the fifth plus y to the third. Alright, I'm going to underline things that are like terms and then put a box around other things that are like terms. I see I've got two things that say x to the fifth. Now, I'm going to combine those, x to the fifth plus x to the fifth. What does that give me? Well, to know that, I have to remember that there is an understood coefficient. An understood coefficient, just like there's an understood exponent of 1 here, there's an understood coefficient, that number out front, of 1 in front of both of these. So, 1x to the fifth plus 1x to the fifth gives me 1 plus 1 equals 2x to the fifth. Do not change the exponent. You add the coefficients, you don't change the exponents. It is not 2x to the 10th. You just combine the coefficients. So that's 2x to the fifth. Now let's combine these two. Y to the third plus y to the third gives me, again, 1 plus 1 gives me 2y to the third. Keep the variable and the exponent the same. Okay? You're just combining your coefficients here. So 2x to the fifth plus 2y to the third. I box that in because I cannot combine those two because they do not have the same variables or powers. They don't have the same variable or the same power. X, this one's x, this one's y. Alright, let's go here. I've got 2k squared minus 3k squared minus 2k squared plus 4k squared plus 2k x to the fourth plus kx to the fourth. So again, I'm going to underline everything that is a like term and then box in the other parts that are like terms. That's one strategy to help you keep track of all of your like terms. You can underline, box in, circle, whatever helps you. So I've got, again, these have the same variable, k squared raised to the same power. So 3k squared minus 2k squared. I'm just combining the coefficients. 3 minus 2 gives me 1k squared plus 4k squared. I'm going to bring everything else down. Plus, I could go ahead and combine these two. 2kx to the fourth plus, again, there's an understood 1 right here, plus 1kx to the fourth. Those have the same variables raised to the same power. So 2 plus 1 gives me 3kx to the fourth. I'm just combining the coefficients right there. Now I've got 1k squared plus 4k squared. Okay, those two I combine because they have the same variables raised to the same power. So 1 plus 4 gives me 5k squared. Then I want to bring this part down. Plus 3kx, 3kx to the fourth. Now can I combine these two? Well, this has a k squared. This has a kx to the fourth. Those two do not have the exact same variables raised to the exact same power, so I cannot combine them. Okay? Here. 2x squared y squared plus xy minus 8y cubed. Sorry, I said y squared there. Minus 8y cubed x squared minus 5yx. I have to figure out if these are like terms or not. Okay? 2x squared y cubed. I have an x squared and a y cubed. Here I have a y cubed and an x squared. Okay? A y cubed and an x squared. They're in different order, but that does not matter. It's the same variables raised to the same power. See, this y is raised to the third, and this x is raised to the second. So these are the same. I'm going to box in that minus sign here, because when I am combining them, I want to make sure that I include that minus. And then xy is here, and this is a yx. The order does not matter as long as your variables are the same, raised to the same power. So I've got 2x squared y to the third minus 8y cubed x squared. Again, those are like terms. I just need to combine 2 minus 8. You can change subtraction to addition, change the sign of the second term. Same signs add and keep, different signs subtract. 8 minus 2 gives me 6. Take the sign of the higher number. 8 is higher, so that's a negative 6. Because I've got to make sure that I see that this is a minus in front of this 8 squared. Okay? So 2 minus 8 gives me negative 6. Then I've got x squared y to the third. I don't change my variables or my powers. I keep those the same. Now I need to combine this xy. Remember, there's an understood coefficient of 1. So 1xy minus 5yx. Okay? Again, I can go up here if I need to. 1 minus 5. Don't forget that this is a subtraction sign. This is a minus sign right here. So 1 minus 5. I change subtraction to addition. Change the sign of the second term. Okay? 1 plus negative 5. Same signs add and keep, different signs subtract. So I subtract those two. 5 minus 1 gives me 4. Take the sign of the higher number. That is a minus. 5 is larger. So this is minus, or a negative, 4xy. Okay? 1 minus 5 gave me this negative 4. So I've got 6x squared y to the third minus, or this is the same thing as plus negative 4xy. You can write it either way. Both of those answers are acceptable. I'll write it both ways just in case you like to see both. Minus, 4xy. Okay? These are the same, because remember, we always change subtraction to addition and change the sign of the second term. So those two are the same. So minus. Now, can I combine it? These. This is just two different ways of writing the same thing. Okay, I didn't combine anything. Just two different ways of writing the same thing. Now, can I combine these two? No, they do not have the same variable raised to the same power. This has x squared. They both have x and y, but this x is squared. This y is cubed. This x and this y are not squared or cubed, so I cannot combine those two. So either one of those are fine. Two different ways of writing the same thing. Alright, we're going to skip this one. We'll do a lesson practice problem that is similar to that one. Or we may do this during the lesson practice. But for now, skip it. Alright, that's all for this lesson.